welcome back to our channel. So in the previous session we have seen the advantages and the limitations of arrays. So in this session we will go with the list implementing linked list. Right. What's the difference between the array and linked list? So in the previous session we have discussed that in array the elements are stored in contiguous memory locations, right? So here in list that is not required. That means the elements need not be stored in contiguous memory locations. The elements can be stored in any location, but as the name itself indicates, there will be a link between one element and the other element. So we have to establish a link between the one element and another element. That's why these elements are need not required to occupy in the contiguous memory locations. Right. For this we need to create a structure for a node. So here an element is represented as a node. Element is represented as node. So because here a node consists of two fields. So previously in the arrays, element means only one field, that is a value. So let it be either 10 or 20 or 30, right? And so on. So this is called elements. But here node means it consists of two fields. First one is data field, second one is address field, address or pointer field or a next field, right? In this data we have to insert the value, that means this type of data. So it may be integer, float, character, string or anything else. The actual value will be stored in data. What about this field, the additional field? In this additional field, the name itself indicates it will represent the address of next node, the address of next node. So this is the link of another element. That's why the elements need not required to occupy the contiguous memory locations. So different elements can have a different memory locations, but here we are just establishing a link. So one element, in every element there will be a one field called address field, which consists of address of the next node. So that's why we have to consider it as a node rather than element. So how to represent this node? Representation. How to represent a node? So a node is represented in two fields. See, so this is the data field, this is the next field. This is the data field, this is the next field. Then if list contains two elements or three elements, that means three nodes. So if list contains three nodes, see, let us take 10 and the memory location is 1000. The memory location is 2000. 30 30, the memory location is 3000, right? So three nodes, so 10, 20 and 30. The address of 10 is the address of 20 is 2000, the address of 30 is 3000. So how to represent these elements? See, 10, 20, 30. So here, this is the, we know that this is the data, this is the address of next node. So here we have to store the address of next node. What is the next node? 20. What is the address of 20? 2000. So here the 2000 will be added. Here, coming to the second node, 20 is the value and the corresponding next, that means address field, it will save the address of next node. What is the next node? 30. So what is the address? 3000. So 3000 will be stored here. Coming to the third node, 30 is the value and what is the next field? That means address field. So here 30 is the last element. So obviously it will be null. So that means the last element, the address field will be fixed with null. So it indicates the list, the end of the list. It indicates the node is end of the list, right? And this linked list will be having the head and tail. The two other concepts, that is head and tail. So head will be the starting element, tail will be the ending element. Head, tail. The name of the node, right? So head and tail are name of the node. The first node name is head, the last node name is tail. So if it is having some 40th element with 4000 address, again we have to use the another node, that is 40, and here we have to insert 4000. Here it will be null and the tail will be here. Hope you understood this one, right? So a node consists of two fields. So far we have studying regarding these elements, only the element, but here we have to treat it as a node because it consists of two fields, right? So before going to the program, first we have to create a structure for this node. So if it is an element, we can directly write with a data type. We can declare it with a data type, that is int or a float or a double or anything else, right? So by using the primitive data types, we can declare the variable for assigning the element. But coming to this node, how to declare a node? So here it is having only one element, so we can directly use the primitive data type. Here it is having two fields, so for every node there will be two fields, right? So how to declare this node? So we had a data structure which can accept multiple elements of different data types. So here the data can be anything, that means any data type, right? So it can be integer, float, character or a string, whatever it may be, right? So second one is purely address. So we know that if in order to store the address, we have to create a pointer. So this is a normal primitive data type. This is a pointer variable. So we have studied in a C language, it's in order to add two different elements with the different data types, what we have to implement? We have to implement the structure, right? So structure is a collection of multiple elements with different data types. The same thing we have to apply while declaring a node, because it consists of data and data. First we will declare a node and then we will insert the elements, or we will create the list and then we will display in this session. Hope you understood the basic representation and how the node is represented and how the node, what are the fields available in this node. Now let us see declaring a node. Yeah, here we will write data and next. We can simply write struct node. We have to create two things. One is data, next. So simply we can write an integer value, int data. Second one is a pointer which is pointing with the self node, right? So which is pointing the self node. So we have to create struct node star next, right? So this is the declaration of a node. So here we have to declare a variable, that is some star new. Okay, see, this is for data, and next is a pointer variable, but it is a self pointer because this is also a field of the same node. It is also a field of same node. So we have to write a pointer variable of the same node. So that is called the struct node. So if you want to declare a variable, see, if you want to declare a variable, so just you right. So let it be consider this structure. So into data float percentage. Let us take this one. So if you want to create a variable, structure variable, what we have to do? So we have to the syntax for structure variable is struct node some s1, right? Struct node s1 is used to declare a structure variable. See, so s1 will be consists of data and percentage, isn't it? Right. Now here the same node must consist of a pointer. So how to create a pointer variable? Struct node star p, that's a pointer variable, pointer structure variable. So the same way we are using the same thing, struct node star next, that means self pointer, the pointer, right? So this is called self-referential structure. The name itself indicates self-referential structure. So reference means the pointer, self, that means which represents the same node, which is a part of the same node, right? And here instead of using the normal structure variable, we have to use or we have to declare the pointer structure variable, because if it is a normal structure variable, see, hope you understood this one, right? Self-referential, because one is data, another one is next, which is also representing the same node. So for this we have created this one. So normally if you create the structure variable struct node new, it will be having a data next. Excuse me. Next. So here there is a problem, because here data is a value whereas next is a address. So we can't store the address in a normal variable. So we can store the address in pointer variable. So for this purpose, we have to create the pointer variable. So all the structure variables for these nodes are pointer variables. Star new. Hope you understood. Don't get confused. So if it is normal structure variable, that variable will be having two fields, data and next. Data is normal data type and next is a address. So a normal variable can't store the address. So in order to store the address, we have to create the pointer. So that's why we are creating the pointer variable. Now this pointer variable will be having the data and address. So this is possible, right? So next, after creating a structure, we have to allocate the memory. So we have seen the drawback of memory allocation is the main drawback for arrays. That is a static memory allocation. So here for every node we can have a dynamic memory allocation by using malloc function, right? Next we have to allocate the memory dynamically. New typecast, for which we have to allocating the memory. Struct node star pointer variable. This is malloc. How much memory should be allocated? Size of operator is used to retrieve the size occupied by that particular data. Size of struct node, right? So this is for dynamic memory allocation. So this statement is used to allocate the memory dynamically. So for every node, before it's getting the value, we have to allocate the memory dynamically. So this is first a typecast. What type of for what type of data type we are allocating the memory, and a malloc function is used to allocate the memory. So how much memory should be allocated? That means the size of struct node. So the size will be calculated and that will be allocated to the new. Here new is a variable. New is a structure variable, structure pointer variable. So here new will be having both data and next. Hope you understood this one. Right. So this is all about the introduction. Now we will create a list and display the list. So as I have said that every list will be having the head and tail. The head will be the starting position and the tail will be the last position. So initially we have to assign the head and tail to the first element, because if there is a one element, we have to assign the head and tail to the same element, same node. If you keep on creating a list, if you keep on adding the list, we have to change the tail. Okay, hope you understood. So if there is only one node, that itself is a head and tail. If it is having a two nodes, the first one will be the head and the second one will be the tail. Let us see. So this is a structure. So I will write the structure here. Right. Creating a list. So if you want to create some 10, 20 and 30, see, first we have to allocate the memory and then we will get the 10 and initially it will be null. 10 and null. Now this will be the head, this will be the tail. Okay, head, tail, new. Next, second iteration, the new will be this one. In the second iteration, the new will be this one. That means whatever the elements we are inserting, that will be the new. Now see here, head is 10, right? Tail is 10, null. The address position is null. Now it is not an empty list. It's not an empty list, right? It is a list with one element. So head will be fixed. Head will be fixed. Okay. Now coming to the tail, what we have to do? We have to establish the link first. Establish the link first. So what we have to do? First, tail of next. So here head and tail are also nodes, right? So similarly star new, similarly star head, comma star tail. So head and tail are also the nodes. Tail of next, that means the tail of next, this one will be assigned with new. Hope you understood this one. Tail of next. Here tail is this one, 10 and null. Tail of next, and that means the address part of a tail will be assigned with new. So let us take the address positions 1000, 2000, 3000. Now what is the new address of new? 2000. So here it will replace the null with 2000, right? Next, tail should be changed. Now the tail will be new. The tail will be new. So that's why again we will have the second element, that is 20, and now it is null. Okay, hope you understood. Initially the new, it's a new, the new will be some garbage and null. So whenever you are taking 10, this garbage value is replaced with 10 and the address bar will be, address position will be null. So head and tail will be assigned to new initially, right? See, and whenever you are inserting the 20 element, first we have to establish the link. So this is very important. First one means establish the link. Next, update value. Sorry. Create a node. Okay, create a node. So tail is equal to new, this one. So here the tail is replaced and it is assigned here itself. Okay, so head is having the two fields 10 and 2000, and the tail is having the fields 20 and null. Now once again in the next iteration, the new will be the third element. New will be third element. Now again, first we have to establish the link. Tail of next. Tail of next. So this is the next. This is the data. Right? So tail of next is equal to new. New means 30. Right? 30 of 30. The memory allocation, the memory address of 30 is 3000. So that will be assigned to tail of next. So this is very important. We have to follow this thing. This is the most important. First establish the link. So 3000 and then tail is equal to new. Assign 30 null. right? So tail will be assigned here itself, right? So this is for creating a list. So we have to apply this in loop, so that how many number of elements will be created in that list, right? So I will write the program and I will explain the logic. I mean, we will trace that. First, let us write the code and we will trace it. So after creating this one, we have to use a memory location, dynamic memory location. Some new is equal to struct node star malloc size of struct node, right? So new, every time the new will be allocated. See, okay. So we'll keep this in loop. So for every time the new will be having, so new struct node star malloc size of struct node, right? So once the memory allocation is done, then we have to take the value. Scanf some %d value, read the value and assign the value to head. New of, so here it is a pointer, right? This is a pointer structure variable. So we know that the pointer structure variable accessing the data members is done by using the array. So if it is a normal structure variable, that variable we can access the members by using the dot operator. If it is a pointer structure variable, it should access the members by using the array, I mean the arrow mark. Data is equal to a value and new of next will be null initially, right? Now we'll check the condition for head, if it is having the single element or multiple elements. So if head is equal to null, so we have created the variables but we are not assigned. So if head is equal to null, what we have to do? Both head and tail should be new. Head is equal to new because both will points to the first element itself. Tail is equal to else condition, that means if it is having multiple elements, right? So then we have to follow the same procedure. That means first we have to establish the link and then we have to change the tail. Tail of next is equal to new. This is for establishing the link. Tail is equal to new, right? So this ends the code. Now just write printf y to continue and to exit. Flash stdin, because we have to read the character. So read the character scanf %c $c h. Close the while loop. Whenever ch is equal to y, continue the loop until ch is equal to y. Whenever you press n, automatically it will be exited, right? Hope you understood this one. This is for creating the list, creating the list. So if you trace this one, let it be some 20 with 1,000, 30 with 3,000, some 50 with 5,000. The memory locations. Okay. Now see, first value. So just above this loop, you just declare the value, declare the ch. I have skipped everything, right? Just I am writing the logic. First, take the value. So value is equal to some 20. Value is equal to 20. Now new of data. So new consists of data is equal to value. That means here 20, here it will be null. Next, head is equal to null. So initially we have declared this head and tail, but we are not initializing. So automatically head will be consisting of some garbage and null. Similarly, tail will be also having some garbage and null. Tail is also having the garbage value and null. Now see, if head is equal to null, yes, head is null, then head is equal to new. So head will be again 20 and null. Similarly, tail is also pointing the same. Head and tail will be 20 and null. Now if part is if part is executed, so else will be ignored. Automatically y to continue and to exit. If you press y, again it will check the condition ch is equal to y, so it is true. Again it will go with the new. Now the new will be this ends with the first iteration. So now there is a node 20 and null, and the new will be the next node. That means the memory will be allocated for the new, and scanf value, some value 30 will be assigned. So 30 will be assigned to new of data. That means a 30 here, and next is null. Here it will be null. Then if head is equal to null, so this is the head and tail. Right? This is the head and tail. Okay. Now head is not a null because head is pointing the first element. Obviously, then this condition will be failed, else part will be executed. In the else part, tail of next, that means null. Here it will be null, so that will be assigned with the new. So new address is 3000, so that will be assigned to tail of next. So here null will be replaced with 3000, and then tail is equal to new. Tail is equal to new. So obviously one more node will be created. So here 30, here null, and the tail will be replaced with this one. Right? This ends. Obviously again y to continue and to exit. If you continue with y, it will go with here, it will check the condition, it's again true, again a new. That means iteration completes. Here again the new is a memory allocation is created, and value, scan value, so 50. So 50 and null. Right? If head is equal to null, head is not a null because it is pointing with some element. So this part will be ignored, else part will be coming. Tail of next, here tail is 30. Right? See, 20, 3000, 30, null. So this is the head, this is the tail. So tail of next is this field. So this is the next field, right? Is equal to new. What is the address of new? So the address of new is 5000. So this null will be replaced with 5000. And then tail is equal to new. So obviously a tail will be created here with a 50 and a null, and the tail will be removed here and it will be assigned here. Right? Next, printf y to continue and to exit. if you press n, while checking the condition ch is equal to n, that means a false, automatically it comes out from the loop. So finally the list will be 20, 30 and 50. So 20, the node 20 is pointing the address of 30, and the node 30 pointing the address of 50, and the node 50 is having null because the node 50 is the end of the list. Right? So hope you understood this one. The creation of a list, a simple thing, a creation of a list. And then the second one is we have to display the list, display the elements of a list. See. So we will see the display elements and we will stop here. We will see the display and we will stop. In the next sessions we will go with the next further operations. Display. See, here we have created already some nodes 23,000 pointing the next node, that is 35,000 pointing the nodes 50 and null. So this is the head, this is the tail. Right. For display, so we have to move the head to the empty. Right. So till the head moves to the empty, we have to display the every node. So for that we will take one more variable called temp. Temp is also similar to head and tail. So first we will assign the head to temp. So obviously the temp will be here. The temp will be here. Next, write down the loop while temp not equal to null. Temp not equal to null. Right. What we have to do? We have to print everything. Printf %d temp of data. So initially it will be head, so temp of data 20 will be printed, and next we have to move the head to the next one. So we can't move the head to the next one, so that's why we are assigning the head value with a temporary variable temp. So temp is equal to temp of next. Close this one. Simple thing. So this is the only logic for displaying the list. So let us trace here. So first temp is equal to head. Here temp will be this one. Next temp not equal to null. So true. Temp of data will be printed here. Next temp is equal to temp of next. So now temp will be temp of next. That means it is pointing with this one. Temp of next. That means this 3000. Address of 3000 means this one. Now again temp not equal to null. It will check with the null condition. So it is again true. So temp of data. That means 30 will be printed. And again temp of next. So it will be assigned with this one. Now again temp not equal to null. Yes. So temp of data. So 50 will be printed. And the temp is equal to temp of next. There is no other node. So that's why it will be assigned to null. So temp not equal to null. But here the temp is null. See here the temp is null. The condition fails. Automatically it will stop. So we are having the 3 nodes with 20, 30, 50, and here also we are displaying the 20, 30, 50. Right? So here we have to create a temporary variable, and just we are moving the temporary variable to end of the list. So whenever the temp is equal to null, automatically we can stop the loop. We can terminate the loop. Right. Hope you understood this one. So don't get confused. It's a very easy concept. So A normal element means storing a single value, but here the list consists of a node which is having two fields. One is a data field and another one is an address field. So here a variable consists of a multiple elements with the different data types is represented as a structure. So here we have to create a structure, and in that structure a normal variable can't store the address, so we have to create the address, that means a pointer variable which represents the same. That's why we are using the self-referential structure. And also the variable should have both the value and the address, so we are creating the variable as a pointer variables for representing a node, right? So here the main advantage is the elements can be stored anywhere, because we are establishing a link between one element and another element, right? And also we are using the dynamic memory allocation for the allocating the memory. So hope you understood. So we have covered the list introduction and how to create a list and how to display the list. So we'll stop here, and in the next session we will go with the insertion of an element in different positions, at the beginning, at the middle position, at the ending position. So how to insert an element at the beginning, middle and end. So in the arrays we have seen, if you want to insert an element at the beginning, all the elements should be moved towards its right side, and then we have to insert the element. So that doesn't happen in the concept of list. So that we will see in the next session. So insertion and deletion, two more we have to see, right? So let us stop here. So if you really understood my sessions, like my sessions, share my sessions with your friends, and if you are having any doubts, please feel free to post your doubts in the comment section, so that I will definitely try to clarify all your doubts. And don't forget to subscribe to our channel. Thanks for listening. Thank you very much.